Hello students, let us continue with our topic of Newton's laws of motion, but this time with friction. So we are now studying Newton's laws of motion with friction. So this is our topic which we are starting, friction in Newton's laws of motion. So let us start with illustrative examples. So in this case, let us refer to our class notes, page number 3. So on page number 3, we have illustrative example number 1. So illustration number 1. So what does it say? So in first question, we have to find the direction of kinetic friction. Case 1 on a block exerted by the ground, and case 2 on the ground exerted by the block. So let us first see the diagram. So we have a block and it is kept on a ground, let us say. So in this case, a force of 1 Newton is applied towards left. Mass of block is 1 kg and its velocity is given to be 5 meters per second. So the first question says, find direction of kinetic friction. On block by ground. So in this case, the friction will obviously be kinetic friction because there's relative motion between the block and the ground. The block is moving with 5 meters per second with respect to the ground. So because there is relative motion, there is kinetic friction in this case. And we have to find the direction of kinetic friction. Let me remind you the concept. The concept is direction of kinetic friction on body A in contact with body or surface B is opposite to relative motion of A with respect to B. So in this case, let us consider body as A and ground as B. So the direction of kinetic friction on body A in contact with body B is opposite to relative motion of A with respect to B. So velocity of A with respect to B is in forward direction. So obviously kinetic friction on body A will be in backward direction. So answer to first part of the question, kinetic friction on body A is in backward direction. Its value is mu n and it is constant. And its value will be 1g is equal to n. So mu 1g, this will be the value. In the second part of the question, direction of kinetic friction on ground exerted by the block. So of course it will be opposite because action and reaction. If friction on body is in left direction, then friction on ground will be in right direction. So friction on ground is in right direction, friction on body is in left direction. That is the concept. So after this, let us move on to the next question. So in this case, we'll take next page. So in next page, we have question number 2. So illustration number 2 of our class notes, it says, all surfaces shown in the figure are rough. Draw the friction force on A and B. We are given 2 blocks. Suppose this is block A and this is block B. The velocities are marked 10 meter per second and 20 meter per second respectively. This is the situation. They are kept on ground. Now in this case, we have to mark the friction force on A and B. So obviously we'll use the same concept. Direction of kinetic friction on A is opposite to relative velocity of A with respect to B. So if I consider the direction of velocity of A with respect to B, so in this case, B is the observer. If I talk about velocity of A with respect to B, who is the observer? B is the observer. So let me become an observer here and I sit on body B. So what I will observe while sitting on B, A is moving in backward direction. Why? Because actually I am moving in forward direction with 20 meter per second and A is moving in forward direction with 10 meter per second. So I'll feel B is lagging behind me. So I'll feel as if the direction of kinetic friction on body A with respect to B. So first of all, velocity of A with respect to B is in which direction? So I'll feel B is moving backward. So B is moving backward. Sorry, I'll feel A is moving backward while sitting on B. So A is moving backward. So velocity of A with respect to B is backward. So friction on A will be in forward direction. So kinetic friction on body A is in forward direction. Next, let us consider body B. By action reaction, friction on body B will be in backward direction. So this is about the friction between body A and B. Let us call it F1. Friction on A, F1 in forward direction. Friction on B, F1 in backward direction. If at all there is friction between B and ground, then according to the ground, B is moving forward, so ground friction will be backward. Let us say F2. Finally, if I consider ground, the kinetic friction on ground will be F2 in forward direction. So these are the direction of friction in this illustration 2. So let us now move on to our next illustration, which is illustration 3. So let us take it in another page. So our second question, which we performed just now. So let us go to third question. So in question number 3 of our class notes, we have a block of mass 1 kg. So let me draw the block of mass 1 kg. So this is our block and this is our ground. And a man is pulling this block. So block has mass 1 kg. It is kept on a rough horizontal surface having coefficient of static friction, which is 0.2, mu k, which is 0.15. So in this case, we have to discuss the frictional forces if a horizontal force F is applied by the man. So let us see various table which we are given. There is a table which is given to us. So in various cases, serial number 1, 2, and 3, we are given the value of F as 1 Newton, 2 Newton, and 2.5 Newton. So first, let us calculate Fs max, the limiting friction. So Fs max will be mu s into n. In this case, let us find the value of n. This is 1g, which is 10 in downward direction. So 10 is Newton in downward direction. Then we have normal reaction. So normal reaction is 1 Newton in upward direction. This is normal reaction. N. So in this case, what we can find is N is 1g, which is 10. So N comes out to be 10 because there is no vertical motion. So N is 1g, which is 10. So let us see once more. So in this case, N is given as 10 Newton. Now, after this, uh, let us calculate the value of mu s n. Mu s is given as 0.2 into n is 10. So it will come out to be 2 Newton. So Fs max comes out to be 2 Newton. Then let us consider kinetic friction Fk. It is mu k into n, which is 0.15 into 10. So it comes out to be 1.5 Newton. So kinetic friction is 1.5 Newton. So we can say when applied force is 1 Newton, then there is no motion because it is less than, when applied force is 1 Newton, it is less than maximum value of static friction, which is 2 Newton. So there is no motion. So we can say for 1 Newton, there is no motion. And static friction of 1 Newton will act. There will be static friction, which is 1 Newton. And 1 Newton forward direction applied force, 1 Newton static friction backward force, 1 cancels and no motion occurs. In second case, we have 2 Newton force. So when we apply a force of 2 Newton, it is equal to static friction. So in that case, we can say 2 Newton force leads to static friction maximum value. And in this case, we have a borderline case. Applied force is 2 Newton and static friction is also 2 Newton. So in second case, we can say that 2 Newton applied force will be the verge of slipping. So we can say in this case, the body is on verge of slipping. We will just slip. And we can say in that case, kinetic friction will start acting. Kinetic friction will act. Okay. So in this case, kinetic friction acts. Okay. So when we apply a force of 2 Newton, kinetic friction acts and the body just moves. Then let us take third case, 2.5 Newton. So if I have 2.5 Newton, what will happen? So when applied force is 2.5 Newton, we have, in this case, let me draw a slightly finer line. So 2.5 Newton, that means that is greater than static friction. So applied force is greater than static friction. So in that case, what will happen? Applied force is greater than static friction. Capital F is greater than static friction maximum value. So kinetic friction acts. And in this case, what will happen? Kinetic friction acts and there is relative motion. So there will be relative motion. So in this question, what are we asked? What is the value of friction? If kinetic friction will act, it will be 1.5 Newton. So in first case, we can say kinetic friction. First case, we can say static friction acts, which is 1 Newton. Second case, we can say Fk kinetic friction acts 1.5 Newton. Third case also we can say 1.5 Newton kinetic friction acts. In both these cases, second and third, we have motion. First case, we have rest. So this is how we solve this third question. I hope you understood this. Let us move on to next question, which is fourth question. In the fourth question, we are given a block. Let us say this mass is m and it is kept on a surface. Surface is something like this. Now, coefficient of static friction is given as mu s. In this case, we are given that a force F is gradually applied and there is a string here. So there is a string here in which we'll have tension and a applied force capital F, which is varying. It is increased from 0, is applied. So coefficient of static friction is mu s. So we have to draw the graph of applied force. So we have to draw the graph of what? Applied force versus tension force. Applied force capital F versus tension force capital T. So let us see how to solve this question. So let us think about the forces acting. One is mg in downward direction, another is normal reaction in upward direction. Then we have the tension force on this block, which will be in forward direction. So these are the forces acting on this block. So in this case, what will happen? Initially, the force applied, let us say it is 0. Initially, force applied is 0. So when force applied is 0, tension force will also be 0. So in that case, we can say when the applied force is 0, external force, it is increased from 0. So it will be compensated by friction. So in that case, there will be no tension force. So we can say initially, when the applied force is 0, we can say in that case, the tension force is also 0. Now, we have to draw the graph between applied force and tension in the string. So we can say when the applied force is less than or equal to mu s mg, so then there is static friction. Friction is static. And tension will be 0. So we can say till the applied force is increased gradually and it becomes equal to mu s mg. Till then, what will happen? Static friction will act and tension will be 0. So all the way applied force is increasing from 0 to mu s mg and tension force is 0. But now, once the applied force is greater than mu s mg, so then what will happen in that case? We will have a friction force in forward direction because the applied force is in backward direction. Because the applied force is in backward direction, so what will happen? Friction will start acting in rightward direction. The friction force I am showing in brown color, it acts in forward direction. So what will be the equation in that case? Capital F, big force, minus friction, small force, that, and there will be tension force as well. So applied force will be equal to friction plus tension force. So from this equation, I can say T is equal to tension force is equal to capital F minus friction force. The friction force. And what is the value of friction force? It is mu mg. So let us say capital F minus mu s mg. So this is the value of tension force. So this is the equation of tension force. So from this we can say the graph will now start increasing. So capital F value minus mu s mg. So in that case we will have an increasing graph like this. And this graph will make an angle 45 degree. Why? Because in this case this is a straight line. Y is equal to x, where coefficient is 1 plus c. So this is mu s mg, which is a negative constant, negative intercept. So that is here. And the slope of this is 1. That means 45 degree angle is created. So our graph will look like this. This will be our answer. Our answer to this question in this case is this graph formed from this equation, which is equation of a straight line. After this, let us move on to next question, which is illustration 5 of our class notes. So in this case, we have a block having a mass 10 kg. It is kept on a rough horizontal surface as shown. The coefficient of static friction is 0.5 and we are applying a force of 100 Newton on the block. So in this case, what is the minimum force that must be applied on the block vertically downward so that the block does not move? We have to apply some force in vertically downward direction. We have to find its value so that the block will not move. So let us see how to solve this question. So in this case, we are having one more force, which is mg, 100 Newton in downward direction. Then we have normal reaction, which acts in upward direction. So let me show the normal reaction slightly on this side in red color. Normal reaction is in upward direction, which is n. Let us see. So in that case, we have Newton's law equation as F, which is in downward direction, plus 100, which is 10g in downward direction. That equals normal reaction N. So this is our value of normal reaction N in vertical force balance. Then let us consider horizontally. So we have applied force 100. That is equal to, let us say, mu s into N. Mu s value is given to 0.5 and N we have already calculated F plus 100. So let us solve this equation. I have substituted this value of N here. And mu s is 0.5, N is F plus 100. 100 is equal to 1 by 2. So we have 200 on the LHS. So 200 Newton is on there on the LHS side. Is equal to F plus 100. So F comes out to be 100 Newton. So the minimum force which we have to apply in downward direction is 100 Newton, so that the block does not move. So I hope this question is clear to you. So let us move on to the next question, which is illustration 6 of our class notes. So in illustration 6 of our class notes, we have a block having some mass, let us say M. This is kept on a rough horizontal surface again, whose coefficient of static and kinetic friction are mentioned as mu s and mu k. We again apply a force F here. And in this case, we have to find the acceleration of the block for various ranges. So first range will take us, if we have static friction, we know it lies between 0 and mu s n. That means in this case, it will lie between 0 and mu s mg, because n is equal to mg. So we can say in this case, if the applied force is less than this mu s mg, then there is no motion. That means acceleration is 0 if F is less than mu s mg. Second case, if F is greater than, if let us say F is greater than mu s mg, so in that case, what will happen? So there will be relative motion. So we'll have kinetic friction. Then we will have kinetic friction. This value is constant, which is mu k into n. So this will be the value. So acceleration in that case will be net force upon mass of block. Net force will be, in that case, kinetic friction will act in backward direction, which is mu k into n. So net force will be capital F minus kinetic friction, which is mu k into n, which is mu k into mg. This is the net force. So net force is capital F minus mu k into mg upon mass is n. So we can say these are the two answers to our question. If the friction is less than mu s mg, acceleration is 0. If the friction is greater than mu s mg, kinetic friction acts and acceleration will be F minus mu k mg upon mass n. So these are the questions which I think everyone would have understood. Let us move on to next question, which is question 7. So in this case, we have to find the acceleration of a 10 kg block, which is kept on a horizontal surface. So in this case, mu s, mu k values are given to us. Mu s is 0.5, mu k is 0.4. So we have to find the acceleration of the block if an applied force of 30 Newton acts on it. So let us first find maximum value of static friction and kinetic friction. So this mu s into n. This is 10g, and normal reaction is n. So mu s into mg. So mu s into 10g. Let's write the value. Mu s into 10g. Mu s is 0.4 into 100, which is 40 Newton. So we can say maximum value of static friction is 40 Newton. Because the applied force is less than the maximum value of static friction, we can say no motion occurs. No motion occurs. Because applied force is less than maximum value of static friction. Applied force, which is 30 Newton, is actually less than maximum value of static friction, which is 40. In this case, acceleration is 0, which is the answer to this question. Then let us take eighth question. In eighth question, we have to find the acceleration of the block. Similar type of question to what we solved just now. We have a block is stamped on a rough surface, and we have a applied force which acts at some angle. Let us say 37 degree according to the question. So applied force is 40 Newton. Its horizontal component and vertical component we can find. So 40 cos 37, which is 40 into, what will be the value? Cos 37, we can calculate it is 4 by 5, so 32. This will be 32. And 40 sine 37, which is 40 into 3 by 5. So 5 is 40, 24. In vertical direction, we have 24. So we have a block in vertical direction 24 Newton, horizontal direction 32 Newton. These are the components of the forces. 10G, 10 kg block, so 10G will act in downward direction, which is 100, and normal reaction N in upward direction. So these are the forces. Now let us think about the friction. If at all it will be in backward direction. So this is the free body diagram. This is 10G force. Let me draw a divide. This is the free body diagram. Now in this case, we have to find the acceleration of the block. So let us first find the value of static friction maximum value. Newton's law equation states that in that case, vertical direction, we have forces, which are these forces. So N plus 24 is 100. So N comes out to be 100 minus 24, which is 76 Newton. So static friction maximum value is mu s, which is given as 0.5 into N, which is 76. So it will come out to be something like 38 Newton. Now, in this case, applied force in horizontal direction is 32 Newton and maximum value of static friction is 38 Newton. So we can say applied force horizontal component. We can say the applied force horizontal component, which is 32 Newton, is less than maximum value of static friction, which is 38 Newton. So acceleration will be 0 and the object will be at rest. Now, let us move on to next question, which is ninth question. In this case, we have ninth question again. We have a block and we have a rough surface as shown. So in this case, again, we have a 10 kg block and 51 Newton force acts in forward direction, 51 Newton. Mu s is given again 0.5, mu k is given as 0.3. So maximum value of static friction in this case, it is mu s into n. Mu s is 0.5, n is 10G, which is 100. So we have 50 Newton force. So because the applied force, which is 51 Newton, is greater than maximum value of static friction, which is 50 Newton. So here motion will be there. So kinetic friction will act. Kinetic friction acts. So we can say value of kinetic friction is constant. It is mu k into n, which is 0.3 into n, which is 100. So it will be 30 Newton. So we have 30 Newton kinetic friction in backward direction. So 30 Newton acts in backward direction. So acceleration will be net force. Net force is Acceleration is net force upon mass. Net force is big force minus small force, which is 51 minus 30. On mass is 10. So acceleration is 21 upon 10. So acceleration is 2.1 meter per second square. So we can say the answer to this question, acceleration, comes out to be 2.1 meter per second square. So moving on to next question, which is 10th question. So in this, we have various cases. We have to find the value of kinetic, value of friction. We have to find the value of friction, not kinetic. It can be kinetic, it can be static. We have three cases. In all these three cases, we have blocks which are almost attached to a block wall. On the right side, I have shown wall here. These are the wall and this is the block. Now we are applying the 100 Newton force on the block. The block is 5 kg. That means 50 Newton acts in downward direction. Mu coefficient of friction is 0.2. We will assume this is mu s and mu k also. Whenever we have just mentioned mu, we will assume it is equal to mu s and equal to mu k. Almost we'll assume both are equal. Okay. So here we have 500 Newton in case 2. Again 5 kg block. That means 50 Newton downward direction. Mu is 0.2. This is case 2. So like a divider here. This is case 2. Again, I have applied force. In this case, applied force is an angle 100 Newton, making 30 degree with the horizontal. Mu is given as 0.2 between wall and the block. These are the three cases. We have to find the magnitude of friction here. Let us first see what is the value of friction. So, what is the first direction of normal reaction? Normal reaction, let us show by black color. That's in this direction in all cases. Normal reaction. N. So, in first case, normal reaction is equal to 100 Newton by horizontal force balance. In second case, normal reaction is 500 Newton by horizontal force balance. In third case, let us find the component. So this angle is 30. This is 100 cos 30. And vertical, we have 100 sin 30. There is no space here. So let me use another color. So 100 cos 30. Now, if I do normal reaction is 500 Newton, here normal reaction is 100 Newton, here normal reaction. Let us say we can also call N1 first case, N2 second case, N3 second case. So N3 in third case will be equal to normal reaction in third case will be 100 cos 30, which is 100 root 3 by 2, which is 50 root 3 Newton. In all cases, we have 50 Newton in downward direction, which is the weight of the body. Now, why is this body not falling? It can fall, it cannot fall. So let us see if it will fall or not. So maximum value of static friction is mu Sn, which is 0.2 into 100. Maximum value of friction will be 20 Newton. Now, if at all the friction tries to avoid falling, this is 20 Newton, but downward force is 50 Newton. So this will fall down. So it will fall down. So in this case, what is the value of friction? It will be 20 Newton. It will fall. Second case, let us consider 500 Newton. So here also the maximum value of friction is mu Sn, which is 0.2 into 100. No, in this case it is 500 because normal reaction is 500 here. So maximum value of friction will come out to be 2 into 50, which is 100 Newton. So the maximum value of friction can be 100, but downward force is 50 Newton. Downward force is 50 Newton and friction maximum value is 100 Newton, but it is not required. Only 50 Newton is required. So only 50 Newton will be the value of friction. In second case, we will have the friction value, which is 50 Newton. Okay. And it acts in upward direction. In third case, let us consider maximum value of friction. So maximum value of friction is mu Sn, which is 0.2 into normal reaction, which is 50 root 3. So it is 2 into 5, 10 root 3. So this is the maximum value of friction. So maximum value of friction is 2 into 5, which is 10 root 3. Now 10 root 3 is the maximum available friction, but downward force is 50 Newton. So of course, in that case, the body will fall down. And what will be the value of friction? It will be 10 root 3 Newton. So these are the answers to this question. For the first part, what is the answer? Case 1, the answer is 20 Newton. Let me highlight it. Case 1, the answer is 20 Newton. Case 2, the answer is 50 Newton. And finally, case 3, the answer is 10 root 3 Newton. So we found correct answers for all these three cases. So I hope you understood all these 10 questions. They are questions based on static and kinetic friction. Now, let us take next set of questions. The next set of questions, we have question number 11. In this, we have questions based on angle of friction. So we have a block of mass m as shown in the diagram. It is kept on a rough horizontal surface as shown. So we are having a force which is applied on the block at some angle theta with the horizontal. So the value of applied force is F and it makes theta angle with the horizontal. We are given the value of mu, which is the coefficient of friction. It is 0.75. The mass of block is 10 kg. It is to be pulled on a horizontal rough surface with minimum force. We have to find the value of theta. At what angle theta should the block be pulled in part A of the question? What is the magnitude of applied force? That is the next question. So we have to find value of F and the angle theta. So let us try to solve this. So in this case, we have to move the block with minimum force, minimum. So in that case, we can say the block can be moved with minimum force if the force is applied at angle of friction. So for minimum value of F, we will apply force angle theta, which is angle of friction. Angle theta will be what? Angle of friction. So for angle of friction, tan theta, we know the formula for angle of friction. I think everyone knows this. Tan theta we had got as mu. So mu is given as 0.75. This is our formula. Tan theta is mu. And mu in the question is given as 0.75. So theta will be tan inverse of 0.75, which is nothing but 37. This is a standard angle we know. This is 37 degrees. So our answer will be 37 degrees. And what will be the value of F? So F at this angle theta, let us try to calculate. So the magnitude of external force we have to calculate. So in this case, let us try to find the value of minimum force. Now, one force here acting is mg in downward direction. We show in black color. Another force is normal reaction in upward direction. Another force is F component in upward horizontal direction. And finally, we have F component in vertical direction. So this force here will be F cos theta. This will be F sin theta. This will be normal reaction. This will be 10G, which is 100. And there will be a friction force in backward direction. Friction force acts in backward direction. In this case, if there is relative motion, so this will be kinetic friction, which is mu k into n, 0.75 into n. Now by vertical force balance, let us consider the vertical forces. These are the vertical forces. So F sine theta plus n equals 100. N comes out to be 100 minus F sine theta. So theta is 37. So we can calculate the value of n. Theta we already calculated. Let us substitute the value. It is 37. Sine 37 is 3 by 5. So after this, this is the value of normal reaction. Now in the horizontal force balance, I can consider these forces in green color, F cos theta and friction. So F cos theta is equal to 0.75 into n. So F cos 37 is equal to 0.75 into n value. I'll substitute here. So it will be 100 minus F sine 37. So F cos 37 will put as 4 by 5 is equal to 0.75, which is 3 by 4 into 100 minus F into 3 by 5. So this is the equation whose we'll solve and we'll get the answer for minimum value of applied force. So 4F upon 5 is equal to 300 upon 4 minus 9F upon 5. So from this we have 13F upon 5 is equal to 300 upon 4. So 1500 upon 13 fours are 52. So we can think applied forces in this case. Let us think about the applied force. F we have to calculate minimum value. It will be 1500 upon 52. Let us see the calculation once again. N plus F sine theta is 100. Yes. So N is 100 minus F sine 37. Yes. So horizontal force balance F cos theta is 0.75 N. F cos 37 is 0.75 into 100 minus F sine 37. Cos 37 4 by 5. Sine 37 3 by 5. So 4f upon 5 is 300 upon 4 minus 9f upon 20. So here we will have 20. I made a slight calculation error. So here we will have 4 into 5, which is 20. So let us take this term here and recalculate. So 9f upon 20 plus 4f upon 5, we can write as 16f upon 20 by multiplying by 5. This is equal to 300 upon 4. So 16 plus 9 is 25. 25f upon 20 is 300 upon 4. So this and this becomes 100 and 0 cancels. So F comes out to be 60 Newton. So our answer to this question will be applied force is 60 Newton. So this is how we'll solve this question. Applied force F on calculation, we have done the steps. It comes out to be equal to 60 Newton. So this is about the question which we completed for angle of friction. Now let us take a question on angle of repose. So in theory we studied angle of repose. So 12th question based on angle of repose. So we have a block lying on an inclined plane whose weight is 50 Newton. Weight of the block in downward direction is 50 Newton. It begins to slide when the angle of inclination is 30 degree. Find the coefficient of friction. So here angle of repose is 30 degree because it just begins to slide at 30 degree. So angle of repose obviously will be 30 degree. So force here will be 50 sine 30 in downward direction, 50 cos 30 perpendicular to the incline, normal reaction in perpendicular to the incline, and friction will act up the incline. So in that case, we can say N is equal to 50 cos 30 and friction force is equal to 50 sine 30. But friction force has formula mu N, that is equal to 50 sine 30, and the value of N is 50 cos 30. Let us substitute N as 50 cos 30. So this equals 50 sine 30. 50 cancels on both sides. Mu comes out to be equal to sine 30 upon cos 30, which is nothing but tan 30. And the value of tan 30, we know it is 1 upon root 3. So the answer to this question is coefficient of static friction will come out to be 1 by root 3. So this is how we'll solve the question based on angle of repose. Next, let us take 13th question. So in 13th question of our class notes, we have a block which is having mass 1 kg. It is tied to a wall here. So this is our wall and the angle of inclination is 50 degree. The block is connected with a straight wire or a string. The coefficient of static friction is 3 by 4. We have to calculate the value of tension force T. So tension will act up the incline. Mg we can resolve. Its one component will be 10 cos 30. Here we will have 10 sine 30. And friction force, in this case, we have to think what will be the direction of friction. So first, let us say the angle of repose. So let us calculate the angle of repose. So it is tan inverse of mu. We know this angle of repose is tan inverse of mu s. So tan inverse of mu s, it is given as 3 by 4. So tan inverse of 3 by 4 is nothing but 37 degree. So in this case, angle of repose is 37 degree. So the angle of incline is less than angle of repose. So there is no sliding tendency. So there is no sliding tendency. So no sliding tendency means what? The downward force will be balanced by static friction. So tension in the string will be 0. So we can say the question asked us what is the value of tension force? It will be 0 because this 10 sine 30, which is nothing but 5 Newton, is balanced by static friction, which is 5 Newton. It is a self-adjusting force. So static friction will adjust itself, and we know the maximum value of static friction in this case is more than 5. It is mu s into n. So mu s is 3 by 4 into normal reaction is 10 cos 30, which is 10 root 3 by 2. So it will be 30 root 3 by 8, which is of course greater than what? 5 Newton. So 30 into 1.73, let us say 1.8 into 3. 18 into 3 is a 54. 54 upon 8. So this is 7 is a 48. So it is about 7.8 Newton. So maximum value of static friction comes out to be about 8 Newton. About. So 5 Newton is less than the maximum value of static friction. So of course, static friction 5 Newton will balance this 10 sine 30 and this block will remain at rest. So this is how we'll solve questions based on angle of repose and angle of friction. So let us continue our discussion about these concepts. Make sure you understand these concepts very, very well and continue in next session.